Welcome, science fans. Today, we're exploring Mount St. Helens, a mountain with a hidden, explosive secret. Picture a peaceful snow-capped peak in Washington state, part of the Cascade Range, a chain of volcanoes stretching from California to Canada. These volcanoes aren't just scenic, they're powerful geological engines. Mount St. Helens is the most famous, and for good reason. Why are these mountains so dangerous? It's all about what's happening deep below. The Earth's surface is made of tectonic plates, always shifting. Off the Pacific Northwest, the Juan de Fuca plate dives beneath the North American plate, a process called subduction. As it sinks, rock melts into magma, which rises, searching for a way out. Mount St. Helens is one of those escape routes. Before 1980, it was known for its perfect cone, nicknamed the Mount Fuji of America. But geologists knew its beauty was a warning. It was the youngest and most active volcano in the Cascades. Its shape was built by repeated eruptions, each adding new layers. The question wasn't if it would erupt again, but when. When volcanoes like Mount St. Helens erupt, their effects can be felt hundreds of miles away. Ash clouds disrupt flights, damage crops, and cause health problems. Millions live near these giants, making understanding them crucial for safety. That's why scientists monitor Mount St. Helens so closely. It's a natural laboratory for learning how our planet works. The story of Mount St. Helens is a reminder. Beneath serene landscapes, powerful forces are always at work. The mountain's history is a warning and a lesson. It's not just a local threat, it's a global one. Studying it helps us prepare for the future. So next time you see a quiet mountain, remember, it might just be sleeping. Science helps us stay ready. Consider this. In spring 1980, Mount St. Helens sent clear warnings: earthquakes, steam explosions, and a growing bulge on its north side. Scientists set up exclusion zones, but no one could predict exactly what would happen. On May 18th at 8:32 a.m., a magnitude 5.1 earthquake struck beneath the bulge. The entire north face collapsed in the largest landslide ever recorded. Instantly, pressure was released, triggering a colossal sideways blast. A superheated cloud of gas, ash, and rock raced outward at over 300 miles per hour, flattening everything in its path. In minutes, 230 square miles of forest were destroyed. The landscape became a barren wasteland. Then, a vertical eruption sent a mushroom cloud 15 miles high, raining ash for 9 hours. Darkness fell on cities hundreds of miles away. Ash clogged engines and collapsed roofs. 57 people lost their lives, including scientists and residents who stayed behind. The eruption reshaped the mountain, carving a massive crater and reducing its height by over 1,300 feet. Mount St. Helens' 1980 eruption became a landmark event in volcanology. It taught us about the hazards of volcanoes and the importance of monitoring them. The eruption's impact was felt far beyond the mountain itself. It changed how we study and prepare for volcanic disasters. The lessons learned continue to shape science and safety today. Mount St. Helens is a powerful reminder of Earth's unpredictable energy. Its story is one of destruction, discovery, and resilience. Science moves forward, because nature never stands still. After the eruption, Mount St. Helens looked lifeless. Ash and pumice covered everything. Scientists wondered if life could ever return. Many predicted recovery would take centuries, but nature surprised everyone. Survivors like pocket gophers emerged, mixing ash with soil, and creating pockets for seeds. Plants protected by snowpacks began to sprout. Seeds arrived by wind and birds. Prairie lupin, a tough pioneer plant, was first to thrive. Lupins enriched the soil, paving the way for other plants. Insects, birds, and animals followed, rebuilding the food web. Today, the area is a vibrant ecosystem. Forests, elk, and clear rivers have returned. Recovery was faster and more complex than expected. The process wasn't linear. It was messy, chaotic, and beautiful. Mount St. Helens became a living laboratory for studying resilience. The eruption taught us that life finds a way, even after total devastation. Ecosystems can recover in unexpected ways. The mountain's story is one of hope and renewal. Science helps us understand and appreciate nature's tenacity. The lesson: never underestimate the power of life. Science is cool. Even when quiet, volcanoes are never truly still. Deep underground, magma moves and rocks shift, creating tiny earthquakes. Scientists use seismometers to detect these tremors, like listening to a volcano's heartbeat. Recently, Mount St. Helens has had hundreds of small, deep earthquakes. Most are too small to feel, but they signal that magma is slowly rising, recharging the system. This doesn't mean an eruption is imminent. It's normal for active volcanoes. After 1980, similar activity led to slow dome-building eruptions from 2004 to 2008. Scientists watch for patterns. Are quakes getting shallower? Is the ground swelling? Are gas emissions changing? Right now, the quakes are deep and there are no other warning signs. The volcano is sleeping, but not dead. Monitoring helps scientists spot changes early. It's like giving the mountain a regular checkup. Careful observation keeps communities safe. The story of Mount St. Helens is ongoing. Science is always watching. Sometimes, Mount St. Helens appears to erupt, but it's just wind at work. Recently, strong gusts lifted old ash from the 1980 eruption, creating a dramatic cloud. No new magma, no explosion, just weather, not geology. Instruments showed no volcanic activity. This process, called remobilization, is like a dust storm in the desert. Wind-blown ash can still be hazardous, reducing visibility, harming lungs, and damaging machinery. The ash from 1980 remains part of the landscape, shaping the environment long after the eruption. Quick communication from scientists reassured the public it was just wind, not an eruption. The US Geological Survey used data to explain the event and prevent panic. This is science in action, combining weather and volcanic monitoring to keep people informed. Even a quiet volcano can surprise us. Understanding these events builds trust and safety. Data and communication are key. Science helps us see the difference between danger and drama. The Cascade Range is a line of volcanoes. Mount Rainier, Mount Hood, Mount St. Helens, and more. Are they connected underground or independent? For years, scientists thought each volcano had its own magma system. That meant an eruption at one wouldn't trigger another. But new seismic imaging hints at possible deep connections, networks of partially molten rock. It's not a single giant pool, but maybe a complex web. The debate continues, with new data and ideas challenging old models. If connections exist, one eruption could influence another. For now, there's no proof that Mount St. Helens could trigger Mount Hood, but understanding the plumbing is key to forecasting eruptions. Science is always evolving. The search for answers continues. How do you watch a sleeping giant? With science. Mount St. Helens is one of the world's most monitored volcanoes. Seismometers, GPS stations, and gas sensors track every movement and breath. GPS detects tiny ground shifts, signs that magma might be rising. Gas monitors sniff for changes in volcanic gases, like sulfur dioxide. All this data streams to the Cascades Volcano Observatory in real time. Scientists use computer models to spot patterns, earthquakes, swelling, gas spikes. When multiple warning signs align, they can issue timely alerts. This integrated approach is our best defense. Technology and teamwork keep people safe. Science is our early warning system. The mountain is watched day and night. Consider that. For nearby communities, Mount St. Helens is more than a volcano. It's part of daily life. The memory of 1980 shapes local culture and preparedness. Residents work with scientists and emergency managers to plan for future eruptions. Hazard zones are mapped, evacuation routes set, and schools run ashfall drills. Education is key. Visitor centers share the volcano's story and science with everyone. Knowledge turns fear into readiness. After the eruption, towns rebuilt together, forging strong bonds. Today, these communities thrive, embracing their unique identity. Living in the shadow of a volcano means respecting nature's power. Preparedness is a way of life. The story of Mount St. Helens is one of resilience and hope. Science and community go hand in hand. The future is safer when we learn from the past.